All right, so now to finish up our conversation about functions, let's look at a couple of examples of input-output relationships that we can affirm our functions and see what we can do to actually write those functions in our typical equation language. So let's take a look at these examples. I have a t-chart example in the blue, and I have a ordered pair example in red. So looking at the number one example, we have our top row, which represents all of the input or the domain values. So this is the input. And then our second row is the output or the range values, or the output values, or what we call the range. And this is the question we want to ask ourselves. We have these values 1, 2, 3, 4, and 5 are our values of x, and we want to decide, what do I need to do to x mathematically to get the y answer that is below it? So let's look at the pattern here. What do I have to do to 1 to get 2? What do I need to do to the x to get y? What do I do to 1 to get 2? Well, there are two ways I could look at this. Maybe it's 1 plus 1 would get me to 2, right? 1 plus 1 equals 2. Or maybe I could multiply. 1 times 1, or 1 times 2 equals 2. So 1 plus 1 could equal 2, or 1 times 2 could equal 2. In order to decide what it is, what operation links the x to the y, we need to try it out on another pair. So let's look at this second pair. Is it plus 1 or is it times 2? That is the question. Well, let's try adding 1 to 2. 2 plus 1 is, that's not 4. 2 plus 1 is 3. So that can't be the answer. Let's try times 2. 2 times 2 is 4. So that looks good. Let's keep trying that pattern out. 3 times 2 is 6. That's good. 4 times 2 is 8. And 5 times 2 is 10. So it looks like we figured out the pattern. In order to get y, we need to complete the operation 2 times whatever x is. So in other words, we take x, something from the input row, multiply it by 2, and we get the output row. 2 times x equals y. And that is where our traditional y and x functions come from. You probably remember that from last year, but we're going to make sure that you are kind of a little bit better practice, that you're not rusty anymore. So let's try our second example. Same idea, but here remember, the left is x, the right is y. So before in the blue example, the top was x and the bottom was y. In ordered pairs, the left is always x and the right is y. So we're asking the question, what do I need to do to, like in this case, the 1 to get 3? What do I need to do to the 2 to get 5? The 3 to get 7, and so on. So in this case, I could try adding 2. 1 plus 2 is 3. Well, let's try that out in the next one. 2 plus 2 is not 5. Okay, so the adding idea didn't work. Let's try multiplying. 1 times 3 equals 3. Try it here. 2 times 3 equals 6. So that doesn't work. So when we added a number, we undershot, right? Like 1 plus 2 is 3, 2 plus 2 is 4. That's too little. Then when we tried multiplying, like 1 times 3 gave me 3 here, 2 times 3 gave me 6, I overshot. So multiplication is a little too much, and addition was a little too little. So here's what we might try. Let's see if I multiply, instead of by 3, what if I take 1 and I multiply it by 2? 1 times 2 will give me 2. Now how much further do I need to get to 3? Well, plus 1. So 1 times 2 is 2, plus 1 is 3. Let's see if that works in the next example. 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6, plus 1 is 7, and so on and so forth. 4 times 2 is 8, plus 1 is 9. 5 times 2 is 10, plus 1 is 11. So we figured out the pattern. So here's how we might write that. We're trying to figure out how x becomes y. So if I have an x, the first thing I need to do, according to my pattern up here that I've just created or discovered, I need to first multiply x by 2, so 2 times x, and then I need to add 1. And if I do that, I will get y. Or more likely, instead of writing it, it kind of looks here, I kind of like writing it like this because this is the in and this is the out. But traditionally speaking, we would write this as y equals 2x plus 1. And we have created the equation that, that models the ordered pairs in our example. Okay, we are going to leave it at that. We'll do some more examples and some practice in class. But you have the basic idea. We talked about relations, what it means to relate two groups of numbers. Then functions, what does it take to be able to call that relation a function? And then lastly, we just talked about how to take a function relationship of numbers and create an equation that represents it. And so that is all you have to do for tonight. I hope that goes well.